Now we are quickly jumping on to our next very insightful and very interesting panel discussion. Lithium-ion battery manufacturing in India, opportunities and challenges, in which we are going to discuss very interesting discussion points, manufacturing trends in India, new opportunities in cell manufacturing, battery chemistry and whatnot. So may I please welcome our esteemed speakers and moderator for the session. But before that, I'd like to take 2 minutes time so that we can please have the installations done for the panel discussion. May I please request to hold you tight as we just take 2 minutes time for the installation. To kickstart the panel discussion, the last panel discussion for the conference session, the entire conference session for the Battery Show India, may I please welcome Mr. Venkat Rajaraman, CEO Cygni, to please come up on the dais, our first panelist for the session. Also, may I please request Dr. Rashi Gupta, MD Vision Mechatronics, to please come up on the dais. Also, may I please request Mr. Prashant Kumar, Deputy Managing Director, LG Energy Solution India Private Limited. May I please request Mr. ALN Rao, CEO, Exigo Recycling, to please take a seat. Last but not the least, may I please welcome Ms. Jyoti Gulia, Founder, JMKresearch and Analyst, who is a kind moderator for the session today. Over to you, Ms. Jyoti.
Thank you, everyone. Thank you to all the attendees also who are part of this session today. The exhibition, we can see there's a lot of footfall. We've seen a lot of activity. But let's see from our expert panelists, let's have an interesting round of discussion today to understand what on-ground scenario is there in the battery manufacturing space in India. With that, my first question is for you, Mr. Venkat. What are the broad trends that we are seeing in lithium-ion battery manufacturing space in India? Specifically, if you can share any, on-ground activity from big players in terms of battery chemistry, what are the new trends?
Yeah, so Jyoti, starting off with a question which is fairly loaded to begin with, but I'll give you my thoughts and then maybe there are fantastic panelists here, they can add more. I think the question was, generally in terms of what is the trend which is going on, especially from a battery manufacturing perspective. I'll start off with, few trends, but 1 and 2 are easier, but 3rd and 4th may be subject to a lot of, discussions, questions, and so on. One, I think we all now know that, there is a huge opportunity, right? Depending on which think tank that we talk to, right? Whether it is Niti Aayog, whether it is IESA, whether it is Avendas, multiple guys. The battery energy storage as an opportunity is upwards of 100 gigawatt hour, right? Depending on, and this number keeps on increasing every year. So today, if you look at it, conservative estimate is about 160 gigawatt hour by 2030, and we are talking about 100 plus gigawatt for electric mobility and 60 gigawatt hour for all the behind-the-meter applications, right? Whether it is for telecom towers, whether it is for data centers, whether it is for DG offset or for renewable energy integration and so on. Having said that, now let's look at what is India's specific trend, right? So one, if you were to sort of look at it, China has been, ahead of India by multiple years, right? So there the trend is, first you start off with the minerals, started off with cell manufacturing and then went on to pack and then went on to electric vehicles, right? India, because we are late in the game, we are approaching the problem other way around, right? We are starting off with the electric vehicles, then there are battery manufacturers. Now you see a lot of cell manufacturers coming onto the board, and then we are sort of going to get into minerals and so on. So which means that the way in which this problem is going to be solved here is going to be unique when compared to how it is done elsewhere in the world, right? That is one. The second thing was, the underlying cell chemistry is continuously changing. I'm going to let Dr. Rashi and others talk about it in more detail. But the cathodes are continuously evolving, right? You are going more, nickel-rich, less cobalt of cathode, more, variants of LFPs. You are looking at alternate chemistries, sodium-ion coming into the picture and so on. And, your anodes are going more from a graphite to a, more, silicon anode to a, pure metal anode, lithium anode, and so on. And electrolytes are also changing between a liquid electrolyte to a semi-solid to a solid state and so on. So which means that this is going to be a, opportunity and a problem for many of the manufacturers, right? Because how do you intersect the technology curve and how do you do it right so that it can stand the test of time? But I leave it now, but we'll come back to this problem later. So the corollary to that is, I do not think that there is going to be one cell chemistry, a winner takes it all kind of approach here, right? There are going to be multiple cell chemistries that would exist, that would coexist, depending on the application, right? For example, applications such as, for example, telecom, I think the need of the hour is a long cycle life. They can live with a little lower energy density. So, but you would have applications, specific energy which is there. And the last but not the least is the availability of critical minerals, right? So I'm sure that also will have a subsequent discussion, but we got to be cognizant of the fact that we do not have the critical minerals in India, right? And it's a zero-sum game, right? There are only like top 10 countries which is controlling all the minerals. How we are going to handle that is again, we need to handle that. But I think the point is all these 5 points needs discussion so that we understand how this, manufacturing ecosystem for battery is going to evolve. I'll stop the Jyoti, maybe we'll take it up subsequently. Yeah.
Thanks, Venkat. I don't want to start with challenges right away, but let's focus on the key positives. We've got a huge thrust from the government in form of PLI scheme. And LG being a global leading player, Prashant, from you, we would want to know, what impact you foresee because of the PLI scheme in this space.
So first of all, thank you very much for having me. It's a great honor and privilege. And the show has been organized really nicely. And I'm thankful to the dignitaries panel, especially to you, Ms. Jyoti. Coming back on the impact of the PLI, let me begin by saying there has been a really, really conducive and positive policies being drafted from the government of India. The support, the trust, and also the push which the government of India is doing in terms of PLI, it has been immense. Starting from 14 sectors, expanding into various other sunrise industries as well, and then coming up with the ACC as well. Thus the entire gamut is playing a very significant role, and this is putting India at a very stellar location. We are on the curbs of seeing a very significant dynamic shifts in terms of batteries, in terms of localization, under the concept and under the vision of our Honorable Prime Minister Ji, Shri Narendra Modi Ji, for Make in India. I think PLI is playing an extremely pivotal role. As for LG is concerned, definitely India market is a very prime and important market for us. Today, we are already a quite significant portion in terms of LEV segment, and we are equally focused towards automobile sector and also ESS, which initially sir talked earlier. So LG is definitely very keen, and we are monitoring the market. We are focusing the market very closely, and in an appropriate time, certainly the positive decisions will be made. That's all I want to say.
Thank you, Prashant. Rashi, my next question is for you now. I want to know specifically, we are seeing a lot of activity on the battery pack space, but on the cell manufacturing space, what is the activity on ground that is happening? What are the challenges that the space has? If you can talk about some bit on that.
Okay, so you've given me the tough task to talk about the challenges that we have. Okay, see what happens is we have always as a country been a trader mindset. We have never been in the mindset of, or rather hardly been in the mindset of manufacturing. And now when we're talking of manufacturing, we are struggling with many aspects. Number one, supply chain, whether it is for critical minerals or it is for the allied components that are required for the batteries. Then it is for the electronics which is required, because we are also not an R&D country. So we are still struggling with that. Okay, then skill set is another challenge. We did not think that the boom will be so soon and so huge. Nobody anticipated. And now when we are trying to bring this skill set, By the time it is ready, employable, we will be late. That is another challenge. A counter challenge to this is also that people think from the automobile sector that if electric vehicle comes, they will lose their jobs. So they are actually a very good talent pool who can actually upgrade their skills and come to this sector, because we are already short of skills in this new energy sector. Whether it is battery, it is a new technology battery, or it is renewable energies, we are having a shortage of skills there. So after that, the challenge is of quality. I think safety and quality go together. So that's the biggest challenge that the nation is facing today. So these are the 5 challenges in short that I have gathered over a period of time, and I've seen that this is something that we really need to focus, address, and come to a inclusive solution to this. Otherwise, but we are talking of PLI, we are talking of having this 2030 revolution of 30% EVs and even for the storage, there's this new VGF fund of I think 3,000 crores that has come. It will make no sense. All this will not work if you do not have these at least these 5 challenges addressed.
What about the price point?
I have one question to everyone in the room, including my co-panelists here. In India, सबसे सस्ता चाहिए, है ना? कितना देती है? कितना चलेगी? Per kilowatt hour क्या है? I mean, even I'm at the booth, everybody is asking me, what is your per kilowatt hour? I have one counter question. How much is your value? Understand my question well. How much is your value? Tomorrow, if there is a fire incident, tomorrow, if there is a problem with your system, tomorrow, if there is a blackout or a brownout, what is the value that you lose? Assess that and then decide kitna deti hai, kitna kilowatt hour hai. Not before that. So India has been, not just Indians for that matter, everyone should be price sensitive or rather price conscious, but has to take a decision on the value that you create or value that you're getting out of a product or a service. That L1 concept has to go out of the door now. And if we still don't do it, please welcome more safety challenges. Please welcome more issues which are already prevalent. They will become 10x or 20x. And who will pay the price of that 10x and 20x? The common people like you and me. I'm no different from you guys sitting there. I'm no different. Just that Jyoti gave me the privilege to sit here on this side of the table. I'm no different. I will also pay the price of that. Every one of us will. We need to come out of the mindset of that L1, sabse sasta. Okay, it is good to have sabse sasta, cheaper, but not at the cost of quality and safety.
Thank you, Rashi.
Jyoti, allow me to intervene. I think Dr. Rashi had touched some really key essence. I have been in this battery journey for more than 12 years now. We started way back 2010. At that time, everyone was still not very aware about lithium-ion, but the journey has been immense. Dr. Rashi touched a very key important point. It's not always about the price. It needs to be quality. And of course, India has always been a price competitive market. And that is the reason we need to find a better solution for the Indian market, but without compromising on quality. So that's really good said, Dr. Rashi.
Thank you.
Yeah.
Thank you, Prashant, for that. Venkat, Rashi and Prashant have mentioned some bit on the price thing, but I specifically wanted to know that what's the price trend in terms of last 1 year we have seen there is upsurge in the price of batteries, and which I don't know how much challenge that created, and we had seen that Bloomberg has given some number that below $100 things will be viable for EVs. So what is the trajectory as of now that you see, or you want to share anything around that?
Yeah, so I'm sure the mic will be passed on to Dr. Rashi and Sheil. So I'll give you only like 2 or 3 major, how many of you have heard of Moore's law, right? I'm sure many of you have heard of that in the semiconductor industry. Many of you may not know there is an equivalent law for applicable to the cells. It's called the Wright's law, W-R-I-G-H-T. Make a note of that and then check that out. What it says is that for every doubling of the manufacturing capacity, right, the cost comes down by a certain percentage. And for lithium-ion cell especially, it has been proven for the last 15, 16 years, okay? So this is one data point. Of course, the second point is also, there has been a lot of volatility on the pricing, right? Mainly because multiple global factors which are there. But as Jyoti was pointing out, there has been a recent dip in the prices. Many of you may know that, right? And this dip, it also looks slightly artificial in the sense that this may not sustain for a longer period of time. But the bigger thing is, I think, India, if you look at it, we announced the Mines and Minerals Bill last month, right? August 2023. If you read that, I think it is talking about setting up an index, for such things, a lithium-based index for these critical minerals. Maybe I think once we sort of do that, it sort of give us a much better indication in terms of how the price trajectory is going to be. That's all I'm going to volunteer, but I'm sure, take it up, Rashi, all yours.
I'm going to differ from everyone here, and I know I'm going to get the beating afterwards after I step down. I know that. Jyoti is going to tell me that. But I have a very strong opinion that the prices of lithium batteries will not fall. Yeah, I can see it right there on his face. I said I will get that beating, that I'm not going to see them fall so sharply and steeply as anticipated by the BNEF, the most sorted report on the planet today. I don't see that happening. And it could be a camouflage also, where you have, this is a problem that everyone is facing today in the country, where the class B and class C kind of cells are coming as grade A and class A. So that is a problem. That could be a way to show that the prices have come down, but that is not the ground reality. And I don't see that happening for many, many reasons. Number one, mining of critical minerals is going to be really painful and stressful from now on. Second is the geopolitical situation that we all have. 3 is the policy issues that we are still struggling with and not having a very concrete, robust policy in place. And 4 is the manufacturing alignment with the PLI. Now, this is something wherein I feel that if it is aligned well with the PLI, we might see some stable pricing of lithium, but I don't see the prices going down. I've made a very bold and strong statement. I'm going to get the bashing after this. I'm prepared.
Thanks, Rashi. Before I shift my discussion to recycling, Mr. Rao, I just have one more point to the battery manufacturers. When is the first gigawatt of cell manufacturing is expected in India? Any timelines?
No, I think I'll tell you the facts and then maybe we can all figure it out, I think. So today, I think, we talked about the ACC PLI scheme. We all know that the 30 gigawatt hour has been given out, 20 will happen next month, and we also know the players who have done. Let's look at few of the names which are available in the public domain, right? So if you were to look at Ola, they have said that, listen, we are going to do the 21700 NMC chemistry. This is what we are going to do, and this is the timeline, okay? If you were to look at Excite, for example, they had also made their plans public. They are talking about 12 gigawatt hour, first phase of 6 gigawatt hour, 3 gigawatt hour of NMC, 3 gigawatt hour of LFP, right? Look at Amar Raja, though not public, but I think they have made a statement, as part of their disclosure, talking about an NMC chemistry initially, and after 3-4 years, they may move into a variant of LFP and so on, right? And of course, there are others like, Rajesh Exports, Reliance. There are a lot of work which is going on. So my take on that is, I think the first sort of gigafactory is a pretty loaded question, but I'm sure that we will have one version which is going to be available by 2025, because it may not be where we are going to be doing all the cathodes, anodes, everything inside, but we would be, sort of starting off with that, and there is anyway localization mandate as part of the ACC PLI. But all of them, if you were to put together, leaving aside the 50 plus 5 gigawatt hour, there is an additional plan for at least about 50 gigawatt hour extra, right, who have not been part of the. So clearly, I think that's the direction that we are going to do. 2 years from now, same battery show, we'll know the answer actually.
Thanks, Venkat, for that. Now, shifting our discussion on recycling now. Mr. Rao, you have listened to other panelists, the numbers, the players who are talking about their big plans and everything. On the recycling part, what are the trends that you are seeing? What are the opportunities? And specifically, what challenges needs to be addressed, since the industry is very nascent, I would say, as of now?
I would need one day to answer all that points. There's so much information that can be said. Anyway, thanks, Jyoti. In fact, I mean, on the lighter side, recycling is always at the last, and recyclers, the last mile players. And in every conference we come with the last presentations. But however, things are changing. We are not only the last mile player, we're also at the start of the supply chain now. And globally, it's being looked into very seriously. So hopefully, in the next battery show, we will have the sequence changed. I hope so.
We have a dedicated session on battery
Right.
recycling.
All right, numbers. We know, based on various numbers that's there floating around, 60, 70, 100 million units in operation would be there by 2030 of electric vehicles. That's the number that's there. We're looking at something, what, 70, 80, 120 gigawatt hour of batteries that will be available cumulatively there. We're looking at, something around 20 to 30 gigawatt hour of batteries that will be available for recycling. And if I were to say 300 to 400,000 tons of recovered materials by 2030 is available. Of that, we're looking at the numbers at what, around 6,000 million US dollars approximately is the value of the recoverable materials that will be there, commodities. Mind-boggling numbers. Right. Now, who's helping it? It's the policy that's helping recyclers now. The lead-acid battery industry is a very mature industry. The hangover of the lead-acid battery workings is still there, and it's actually getting migrated to the lithium-ion battery side, but things are pretty different on the lithium-ion battery side too. So opportunities are very, very big. The challenges also very big. The government is doing all its bit to help the recyclers establish, at least as far as policy announcements are concerned. Implementation, as Rashi said, is a nightmare. I am also a NITI Aayog committee member who have drafted the battery waste management rules, and also currently I'm a steering committee member of CPCB for e-waste and battery. So I have multiple hats, and I know the challenges that everybody are facing on, all stakeholders are facing, I would say. So challenges for recyclers is absolutely zero support coming in from the government on the finance side. The ACC scheme came in, the Specs 1 scheme came in, 25%, 2 crore threshold, it's peanuts. We're looking at globally around 70%, 80% support being given to recyclers. We are nowhere there for that matter. Are we looking at recyclers or are we looking at refiners? Or both is the question here. We, Exigo, we are basically recyclers and refiners and put up multiple plants in the country. But the challenge for all the recyclers is, with not only the finance, the capital that's required, because recyclers, it's a very capital-intensive business. And you need a lot of patience. It's not just in 2-3 years' time you're able to get your returns and get out of the business or continue business. It needs long working time, you need patience, and technology plays a very, 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 very important part. And there are no easy solutions available there. Everybody have to go through the grind only then you will be successful in refining. Else you are lost out without you knowing your machinery or without you knowing your material, you will become obsolete in 2-3 years' time. Now that's the hard facts and reality. We have gone through the grind for the last few years and we know how tough it is. Globally, claims are being made in a very big way, but I think there is a lot of hollow out there at the bottom. And I'm sure recyclers in India also will step up. And I'm sure we will lead the pack and we will become global best players also in the coming years for that matter. Yeah.
Thank you, Mr. Rao. A follow-up question on the technology side of it. I've heard that most of the recyclers at present are only using mechanical way to recycle the lithium-ion batteries. What is your take on this? And do you think there are any other licensed technologies that are available which players can use?
That's a good question. Technology-wise, there's a mechanical one which is common, and then there is hydrometallurgy, pyrometallurgy, and direct recycling technologies that are available. Globally, for a high yield and good quality, I think it's the hydrometallurgy route that many recyclers use. Water is a friend and as an enemy and a friend in the hydrometallurgy process. So environmental concerns are very, very high. Compliances globally, it's pretty tough. So with regard to technology, indigenous players are there. We at Exigo use indigenous technology, but there are the barks and NMLs and CPETs and CMETs where technologies are available and are given on license. But these are all at a pilot scale. At an industrial commercial scale of a 10,000 tons per annum plant, we know putting up a 10,000 tons plant is a nightmare. And it's taken 4 years for us to actually put up a plant and it's operational currently. So yes, technology is available. Mechanical is pretty easy. Up to the black mass level, people are able to do it. It all depends upon the commodity prices at a global level. Once the commodity prices are on the higher side, you can see a lot of mechanical recyclers active globally. But once the commodity prices goes down, I mean, they vanish in thin air. But the idea here is that technology, the research institutes, the CSIRs and IITs needs to step up, needs to be a part of large-scale industrial plants actively working on the ground, not on theory and not at lab level. That's something which we have recommended to the government and also in a big way. But I believe there are changes happening and hopefully things will be becoming better, I suppose. Yeah.
What about the sourcing? You have said, setting up a 10,000 million ton of a facility. So how, we have seen lead acid batteries mostly informal sector in this. Has the scenario changed anything in last 1.5 years? How are things progressing on the collection side of it? And I want to ask this question to the battery pack manufacturers also. What are how they are helping with the recycling protocols and all?
Yeah. Sorry.
Yeah.
So in fact, predominantly it's been in the consumer electronics sector where the batteries have been coming in a very big way. The demand there currently for electronics is around 4,000 to 6,000 tons or 60,000 tons on a per annum basis, which is growing at a CAGR of around 20%, right? But going forward, by 2030, even at a global level, the consumer electronics batteries the mix would be around 5 to 10% only. It's the EVs that will actually start contributing. We've seen that in the last 2 years' time, the two-wheeler and three-wheeler batteries, there's a flood of batteries that have come in. Unfortunately, it's the B grade and C grade cells that's been dumped into the country. And the quality of cells that we're getting in for recycling is pretty, pretty bad, actually, right? The recovery levels are not really that high. But however, as the industry is growing by leaps and bounds now, we don't find an issue as far as sourcing is concerned. The problem for the country currently being faced is a capacity. Mechanical capacities are being built up, but refining capacities are very low. So the demand for capacity is on the higher side now rather than on the supply side. Yeah.
Got it. Thank you, Mr. Rao. Rashi and Venkat, as a battery pack manufacturer, what are the protocols that you're following for
Yeah,
recycling?
so yeah, I'll take off from where Mr. Rao left. See, today, we have this extended producer responsibility where every pack manufacturer, every OEM, every consumer, every collector, and every recycler, right? They are made now accountable. I think this is definitely a fantastic effort. Thanks to you, I think, for making it happen. Because now every manufacturer, battery manufacturer is required, right, by law to go there and register in the CPCB portal. And we are making sure that the EPR guidelines are followed, right? So this is a step in the right direction. The challenge is, for those of us who had been from the lead acid industry, that also had a great on paper, what needs to be done for recycling. But predominantly it was taken over by the local recycling, right? Predominantly in the informal sector. We cannot afford to do that in lithium-ion because the kind of, the effects of mismanagement is huge. But I think what I'm going to see is that I think next about, next 6 months, 1 year, we will see how the EPR responsibilities are working out. So that is one. The second point that I wanted to make was that, see, the challenge is recyclers would really want, more of the critical minerals, right? More of cobalt, more of manganese, more of lithium, more of, all the critical minerals. And whereas our focus should be to go less reliant on the critical minerals, right? If we can go maybe even an LFP route or even with something with an aluminum and so on and so forth. So there is going to be a, I would imagine that there is going to be a healthy sort of in some which way where we manage the critical minerals properly. The third, today the biggest challenge for somebody like me is not finding a recycler, but making sure that the collection happens correctly, right? As you was pointing out, today a battery pack, if you were to take it from, a consumer, right? Very difficult to know what is the cell chemistry underneath that, right? So I want to go back to the previous presentation. One of the presenters talked about something called as a battery passport, right? Some of you may have heard about it. Today, I think that is the need of the hour for us, right? Today, if I were to look at a battery, I would want to know first what is the chemistry, right? So the bare minimum requirement. I also would want to know from where has the, what is the cathode, what is the anode, when was this done, what is the recyclability, what is the sustainability of that product. All of them are sort of handled through this Global Battery Alliance Forum. I think it's important for all of us to sort of get there. I'll give it to Dr. Rashi and then we'll come back to this again.
Thank you. See, recycling in India has always been a very unorganized sector. We always would call the local kabadi wala, Aaja yaar. He will weigh something and he will take it. What is the today's challenge in recycling is that these unorganized sectors, they understand what can be extracted is only copper and aluminum out of it. ऊपर का plate दिखता है ना battery cell का जाएगा. So what is happening is they are not educated enough and they throw away that material in the garbage or they just give it away in the way as weighing scale के हिसाब से, not understanding that what amount of critical minerals can come out of it. And these people don't understand the value that these people can extract out of the battery recycling and collection of this waste. So what is the need of the hour, as he said, is first is collection, effective collection. Today there are very few, I think 5 or 6 recycling companies around, 5, 6 recycling companies around who have made this tie-up with these EV guys where they collect the faulty batteries or whatever non-repairable, non-reusable batteries for recycling from the dealer distributors. But there is such a big grey market which needs to be addressed. There we need to even give an education skill training to these waste collectors also, so that they know what they're collecting and how much worth they can extract out of it. That is another challenge. Second, the thing is, we are not incentivizing recycling. We are still making it as an extender producer liability. Still, it is a liability. And in India, when there is a liability, nothing works. We are all kitna deti hai na? We are all of that kind of person. Even if we are going to sell the scrap, it's like, "Are yaar, 11 rupees? नहीं, 12 में दे दे." We will negotiate even with the scrap vendor. That is the way India mentality works. That is the way we think. We want to maximize profit everywhere. And you know what? The next billionaire or the trillionaire for that matter is going to be from the recycling industry sitting on there on the last corner. but subject to effective collection of waste, effective skill development and education to the waste handlers, incentivizing recycling at the consumer level, not at the OEM. I mean, OEM to yes, everyone needs incentives. I'm not discouraging them. But what you really need is at the consumer level. Now, so, and you know, the alarming statistics are that 90% of the batteries that are going today in recycling are in warranty claims. And this is a fact. I usually don't give out figures. She knows that very well, but this is a very well proven figure. So we need to address this very at the ground level. So every the whole value chain of recycling has to be incentivized and not subsidized. Then it will work.
Thank you, Rashi. I just want to give one anecdote here. I was speaking to one OEM, and he was giving me reference prices for lead acid. I am getting some 1,000 rupees per itna kg. For lithium-ion, I'm not getting anything. So they have no,
Because they don't know. I mean, for lead acid, they know how to remove the plate, how to remove the acid, and they know how to refurbish it. For lithium-ion, they don't know. That is why you're not getting any money. So first educate these scrap collection and, vendors who are coming, the local vendors, then you'll get a lot of money out of it.
I will see to this business opportunity.
It's a very big business opportunity. I've given it for free to everyone in the audience now and whoever is listening to this.
Okay, going back to our main discussion. Prashant, from you, LG has a global experience. Anything from your international experience that you want to talk about on the battery manufacturing space that you think India will also soon going to adopt?
Thank you, Jyoti, for your question. Yes, I mean, when we talk about our international experiences, by 2025, we are targeting to achieve around 540 gigawatt hour. So that's a massive number across the globe. Currently, we are going for expansion immensely in the US market, along with Europe and Indonesia, where we do have some partnerships with some of the global OEMs, I should say like this. India, as I said in the beginning of my statement, is a very important and prime market, where not only in terms of mobility segment, which is definitely going to play a very important role in terms of volume, in terms of demand, and also in terms of real realization of the usage of the batteries. We also feel that eventually automobile sector is also picking up. For instance, four-wheelers, where some of the Indian OEMs are already playing a dominant role. And with one of the Indian OEM, we also have a partnership, which is already in the public. Going back to the experience of international in terms of manufacturing, while we have three different segments, automotive, ESS, and mobility, which is for LEV, we have different setups in terms of pouch and also in terms of cylindrical. Cylindrical capacities are going quite big, 70 or 80 gigawatt hour. At the same time, we are also expanding our pouch capacities. We have different JVs right in US and also with some of the companies based in Canada. And day before yesterday or yesterday itself, there was an announcement that LG and Toyota is also going forward for some kind of a partnership. So when we talk about the battery domain, LG started this initial business way back in 1992. In 1996, 2001 onwards, the real commercializations happened. So manufacturing is a really big domain. India, as I said, 50 gigawatt hour, out of which some have been allocated. 20 gigawatt hour still left to be allocation. So India is opening up, and all the global players, including LG, I think we are really closely monitoring the Indian market. That's all I can say, Jyoti. Thank you.
Thank you, Prashant. Good to know that. So now, again, I think we can move the forum for audience question, but I have one interesting question without which this session is never complete, which is battery chemistry and NMC versus LFP, lithium-ion versus sodium-ion.
No, it's no more the war of lithium-ion anymore, you know. See, I'll tell you what. In fact, this time just now we have launched graphene, okay, at the graphene chemistry. But I'll tell you what, India needs the right mix of these chemistries. Like he also said, there cannot be one clear winner. We need everyone. We need sodium-ion, we need vanadium, we need lithium sulfur, we need lithium-ion, lithium ferrophosphate, LTO, we need everything. We are such a diverse and a vast geography with a very unique mindset of our consumers. We need everything, and we need the right mix of chemistry, right mix of technologies to attain our energy mix for a complete energy independence. That's my take.
Yeah, so there are few trends which are going to happen, right? One, the energy density is increasing, right? Whether we look at in whatever way, the intent is to, on all the 5 quadrants as they say, right? Energy density being one, safety being another, which is with, solid state batteries and so on, and cycle life being another, and fast charging, right? Ability to charge and discharge. All of them, I think this is one of the most researched, area, right? So this trend is going to continue, and I'm absolutely certain that I think, it's very similar to for those of us in the solar panel industry, right? We were talking about 7.5–8% efficiency not long ago, 10, 12 years back. Look at where we are now. So this is going to happen. That is one aspect of it. Second, I want to also talk about, I think, if you talk about LG, talking about a 500 gigawatt hour of manufacturing, and world over we are talking about excess of 3,000 gigawatt hour, right? So which means that lithium is here to stay, right? I want to, the people are talking about a lot of other stuff, but for us, the BHAG on the table is lithium chemistry, right? Because this is the most proven, most, researched and, globally accepted one. So we would also be on that. But I also agree that we will have to sort of quickly get on to the alternate chemistries, right? Be it sodium. Sodium-ion is already available, right? Some of us are, experimenting with that. Of course, there is going to be a lithium sulfur. There is going to be an alternate chemistry. But the point is, I think, if I were a manufacturer, I would shudder, because how do you intersect it correctly, right? Because these plants takes 24 months, 36 months at a minimum. And you know that you put for one chemistry, it becomes, very not amenable for other chemistry, right? Because fundamentally, the way in which you do are different. We will have to be making sure that we intersect this with the correct one 3 years down the line when, Indian market is ready, actually.
Thank you, Venkat. We can take some questions from the audience.
Hello. Hello. Hi. This is Abhinav from World Resources Institute, India. And I had 2-3 questions in mind when it comes to...
Hold the mic closer.
Hello. Yeah. So this is Abhinav from World Resources Institute, India. I have 2-3 questions. First one is regarding this conundrum between designing for circularity and designing for, resilience. So how is industry looking into it? So ease of getting batteries into the circular economy versus, making more resilient and reliable batteries. Can they both go together? Secondly, what about the responsible sourcing of the critical minerals? Is the industry looking into it? Because, I mean, we don't want India to dirty its hands in future, I mean, with increasing manufacturing capacity, with irresponsibly mined minerals. I mean, and thirdly, can we, I mean, in the recycling space, can we think about an idea? I mean, like you said that the recycling sector is quite unorganized. So can we think about some waste collectors or recycling cooperatives? I mean, as a first instance of organizing this sector.
I think there are three questions. One on the critical minerals, other is on circularity versus resilience. I think we can take one by one. Yeah.
I will take the first one and then, yeah. So I think the first one was an excellent question between circularity and resilience, right? So I think, fundamentally, I think resilience is the key one, right? Today, you want to design a battery that can last for a longer time, right? If you were to look at, Professor Jeffrey Dawn's paper, right, he's already talking about a 1,000,000-mile battery, right? So we are talking about a battery that can outlast, the vehicle in which it is fitted, right? And this is going to happen, right? There is a lot of work which is going on. And I think we need to make sure that, just on the pretext of circularity, we don't, leave out the resilience part of it. We need to design good quality batteries that can last a longer time. But the hand in hand goes is the circularity, right? At the end of the day, it's, there are specific designs people are doing to make this amenable for circularity, right? I'm very sure, that is a topic by itself. But I think both of them are going to be critical. We will have to design for resilience and keep circularity in mind. The corollary to that is also how do you make sure that there is a safe mining, right? Today, this question is, I don't know, rhetoric, because we are dependent on one country, whether we like it or not, right? We are dependent on few countries for the critical minerals. So we will have to, within that constraint, right? That's why we call that as a zero-sum game, because there are only, so much of minerals which is available, and every global, country is vying for that resource. I think it's important for us to, given that constraint, how do we make sure that we handle it, in a clean way, right? In a clean way. I think that's why I think, the Minerals and Mines Act is talking about it in more deeply, right? They're talking about establishing this Kabil, which is, going to go and then vie for the resources. Once we sort of own them, then a lot of things would be coming under our control, actually. Yeah.
Thank you, Venkat.
On organizing the unorganized sector, there can be many different ideas. I mean, and WRI is expert in having more ideas on table. So, I mean, instead of asking me that question, can we have that? I think just go ahead and do it. Who's stopping you from doing it? Because you need that. If you're not going to do it, somewhere or the other, we all will fail together. See, because if I just keep manufacturing and I don't get to recycle, if I just keep mining and I don't utilize what I have to the maximum efficiency today, the human race is going to be extinct. Forget what is going to happen in the battery domain. There will be no humans to use that battery. What is the point then? So please go ahead and do it.
Sir, the question that you asked is a very, very good question. There are hardly any answers for that. I'll tell you the problems that are there. 2016 in e-waste, under EPR rules, the concept of PRO, the concept of collection centers was introduced. I ran something around 35 to 40 collection centers for a few years. In the last 6 years' time, I would have received maybe 200 kgs of electronics from all these centers, I would say. We expect the end consumer to come and drop the units in the collection center. It's not going to happen. Second, with reference to, anybody, for that matter, going and picking up the batteries from source, that's a good ask. Ladies and gentlemen, batteries are very hazardous. The thermal runaway incidents are going to be very high. We don't have guidelines even now yet for packaging, shipping, transportation, warehousing, storage. We're writing the guidelines in CPCB for that. And globally, I'm also a World Economic Forum member. Globally also, the battery passport scheme we've been talking, and many players, producers globally, they do not even know what is the composition of the battery which they are buying and using it in the product. Right? Forget about the ESG or the battery passport and the sourcing and all that. So while the CPCB rules were being framed, the software was being created, and the ask was asked with many producers to give in details about the batteries. We got producers who said that they've got 30% lithium, they're 40% lithium. God knows from where they got those numbers, right? And these were all, I mean, very difficult times, and hence we had to come out with rational ways of doing in CPCB per se. So the answer to that question is, I'm not looking at from the mind to it. What we are trying to preach and what we are trying to tell people is, as a producer, the first time when you buy a battery and use it in your product, would you want to be a owner for a certain period of the battery? Or would you like to be a owner of the commodity for lifelong? Then you would be owning the mine above the ground completely. That's the solution that's being looked at and globally also. And that's the solution even in India that's being discussed now, at least at the board level, in by various producers now. So I believe the change will happen as far as the ownership is concerned, but I think we're still far off, and it'll take a few more years. So the waste collection by the informal sector, I don't think it will happen to the extent where in e-waste it used to happen. And when the guidelines comes in, it's going to be much more stricter on the handling of the used battery itself, let it be from any source per se. Yeah.
Thank you. We can take one last question.
Thank you, Jyoti ji, but I will cross that and I'll ask you 2 questions at least,
Yeah, please.
if you permit. Again, thank
Hold
you.
the mic closer.
Is it fine now? Thanks. Again, thank you so much for an engaging discussion. You made me laugh too much. Now, my question is starting with Rao sir. Rao sir, 2 questions to you. Number 1, LFP is now becoming a reality of the country. It is well known that LFP recycling is almost next to impossible commercially. What is industry's take on this, and how does the recycling industry, plan to deal with this problem? Second, we've seen collection. When she was saying, I was reflecting, we used to save those corks of the glass bottles because retailers used to give back 5 rupees when we used to submit the bottles. Is industry looking to pass on the responsibility of battery collection to actually the OEM producers or the final retailers who are selling these devices or the vehicles to the consumers? Is there a regulation that is going to come which will pass on the responsibility to these guys? Because we have frankly destroyed oceans because Pepsi was not put hold on responsibility of the packaging material it was using. Third question, ma'am, to you. Grade B and Grade C is the reality of India. Is there any systematic approach? I come from pharmaceutical industry. We have absolute testing on every shipment that is done from China. And I can assure you, half of them is absolutely bad, but most of it is checked well and then sent to the industry. Is there a setup that can be set like SGS to test the batteries that are coming to India and regulated enough so that Grade B and Grade C batteries do not come, so that our current producers who are coming up can be competitive? Lastly, if anybody can answer, ESS storage has not become a reality of the country. Is there any regulation happening to enable compulsory ESS? Because we, as a country, we are blessed with sun and wind, but the worst timings of sun and wind to be put together. Is there any thoughts on how ESS industry will shape up? Again, sorry
Let
for
him
the
first
bombardment.
take the recycling, then I'll take the other 2.
LFP, it's a very interesting chemistry. You know, I personally love LFP, right? I love recycling LFP cells. The technologies are available globally. However, it's the question of what's the cost of recycling and refining this, and what are the different types of technologies that you're able to use. Now, is it going to be a mix of a pyro and a hydro, or is it just a mechanical and a hydro, or a mechanical pyro and hydro is the question. Various permutations, combinations available globally, but we have successfully put in a line where we are able to reduce the viability gap to a large extent as far as LFP is concerned. It now boils down to the upstream and downstream tie-ups that we are going to have. And unless and otherwise we are not having those tie-ups for a long term, then it's not going to be that viable and people will shy away from LFP recycling. However, we at Exigo are going great guns with LFP for that matter. Secondly, with reference to your responsibility and liability of collection is always going to be with the producer, right? However, even globally it's the same there. But however, the challenges that are there is, example, you know a company called Cashify. You go to a retail store, from your residence, you can run a diagnostic app and you can sell your mobile phone, right? I have another company where we have developed diagnostics for laptops. So you can sit at your home and run the diagnostic tool and there's an AI-based pricing engine pops up, you can sell it and integration takes place where we are able to ship it and do that. In batteries, now at the point of disposal of an used battery, you will have to look into the SOH level. Each producer has got a different way of monitoring the performance of the batteries. So a universal way, the global level solutions doesn't exist. So how do you work out diagnostic tools remotely to understand the SOH level of batteries at the time of disposal, wherever let it be? If that can be, we are working on that solution already. And once we do that, then we will be able to give a solution for disposal. Ownership shifting from the user to another one. Will the producer own it lifelong? Is it going to be the finance companies or the leasing companies that's going to own? Or it's going to be the end consumer who's going to own? These are open-ended questions. We don't have answers yet. So yes, to answer your last question, it's the producer always who's going to be responsible for collection and recycling of the batteries. Yeah.
Now, your question on grade A and grade B. So, it again comes to the mindset problem. Sasta chahiye. People are not educated enough on what to choose and what not to choose. Problem number one. Problem number two, we do not have enough testing in the country. We do not have enough test labs. Now, if I talk of setting up a test lab, it's a very capital-intensive thing. Secondly, testing is extremely expensive in our country. So people will just test the first batch, which is perfect, and then just in the same label keep on, sending out, you know what I'm talking about now. So these are the certain challenges where all the industry has to come together along with the test labs and form a robust mechanism to stop this happening. And the consumers have to make an aware choice. With all the awareness, you have to make a reliable choice. At the end, it's your life at stake. You are the ones who are going to fight with the insurance agencies. You are the ones who are going to suffer of this. The companies will have their ways to get out. The Indian laws are very beautiful. We know how to twist and turn the tails. I am being very open, blunt, and upfront. The next you asked me was on critical minerals? No. Energy storage. Why energy storage has not become the mainstream? Same reason. There are 2-3 reasons for that as well. Number one is that what if technology becomes better? I've spent so much of money today. I get this question every time. Fine, but you have utilized it for 10 years also, no? You have got your ROI, you have got the money out of it, and still you are having a problem? I don't understand why, number one. Number two, enough cases, demonstration cases on large scale for the CNI sector. They're still anticipating. And then not having an incentive policy in place. So I am not asking for subsidies. Again, I'm repeating this. Subsidy is not going to make this effective. Have a proper incentive in space and have a good metering policy. If these two things comes, ESS will take the mainstream. Renewable energy, solar or wind or whatever will not come without ESS. Make it a mandate. And make it an implementable mandate, not a paper mandate. Diesel is banned in Delhi and NCR. What is it? A paper mandate. We still see diesel gensets running. And it is much affordable to replace them with an ESS. Your ROI is well within 3 years, but still, make it a implementable mandate. That's my answer.
Thank you, Rashi. Yeah.
What a beautiful discussion we had today in front of us. Thank you so much, respected and esteemed speakers, for sharing your eye-opening perspectives on how the scenario is unfolding in terms of lithium-ion battery manufacturing in India and beyond. May I please request our kind moderator of the panel discussion, Ms. Jyoti Gulia, founder GMK Research and Analytics, to please hand over a token of appreciation to Mr. Venkat Rajaraman, CEO Cygni, on behalf of Informa Markets India. May I also request Ms. Jyoti to please hand over a token of appreciation to Dr. Rashi Gupta, MD Vision Mechatronics. May I please request Ms. Jyoti to kindly hand over a token of appreciation to Mr. Prashant Kumar, Deputy Managing Director, LG Energy Solution India Private Limited. May I request Ms. Jyoti to kindly hand over a token of love and appreciation to Mr. ALN Rao, CEO Exigo Recycling. Also, may I take this opportunity as my honor to hand over a token of appreciation to Ms. Jyoti Gulia, founder GMK Research and Analytics, on behalf of Informa Markets India. May we have a very warm picture of the beautiful panelists we have for the discussion today. Thank you so much, our respected panelists and the wonderful audience joining us throughout the session. Thank you for your kindness and sparing your time. Last but not the least, Tata bye-bye from the Battery Show India, as we promise to meet you again next year. Take care. Thank you, everyone.